Hello everyone. In this video we're going to do a classic double integral problem in polar coordinates. All right, what we're going to do here is find the volume of a solid bounded by the plane z equals 0, which is the xy plane, and this paraboloid z equals 1 minus x squared minus y squared. Let's check it out. Okay, so what I'm going to do is, well, do I need to do this? I sort of think maybe. I'm going to sketch the graph of this solid that we're going to find the volume of. So the plane z equals 0 is simply the xy plane. Now let's check out this graph, z equals 1 minus x squared minus y squared. What type of, what's that going to look like? Anybody want to tell us? Satellite, upside down satellite, like a bowl upside down that's facing downwards. Yeah, it's not a satellite. Yeah, it would be like a satellite dish that's facing downwards. And so how can you see that? Well, okay, look, if I let y equals 0, then I get 1 minus x squared. Z equals 1 minus x squared. So z equals 1 minus x squared is a downward facing parabola. And if I let x equals 0, then I get 1 minus y squared. And so we get a downward facing parabola also in those two directions. So you get a downward facing direction one way, downward the other way. Now, if you let z equals 0, you get x squared plus y squared equals 1, and you get this circular region at the base. If you have like z equals negative 3, you're going to get negative x squared minus y squared equals negative 4. So that's going to give x squared plus y squared equals 4. It gives a circle. We don't want to spend too much time on that part. But anyway, that's what that is. That's like a satellite dish that's facing downwards. And so, all right. Here's the thing is that D is the projection of the surface onto the xy plane, which is the same thing as z equals 0. So it's the projection onto the xy plane. And let's sketch D then. So when I sketch D, that's the xy plane. That corresponds, when I have z equals 1 minus x squared minus y squared, I put z equals 0. So I get 0 equals 1 minus x squared minus y squared, which gives x squared plus y squared equals 1, which we know is a circle. And D is that whole region bounded by the circle. So okay, here's your surface. And what we do is you project onto the xy plane. And that forms a disk. So, which has a boundary, the circle x squared plus y squared equals 1. And what we're going to do is we're going to describe this circle in polar coordinates. So in polar coordinates, well, let's just first of all start with, how do you describe a circle of radius 1 in polar coordinates? We write r equals 1. All right, so that's our boundary. So actually, let me start writing what D is. D is r theta. All right, so r is going to go from 0, the origin, which is the pole in polar coordinates, is r equals 0 to r equals 1. So r is between 0 and 1. On the other hand, what about theta? Let me come back. I'm just going to write it down. Let's come back and discuss more. But theta, we start at 0. So this line here is theta equals 0. And then we're just going to go around the circle to pi over 2 to pi to 3 halves pi and back to theta equals 2 pi. So this is how we describe this circle in terms of these inequalities, which makes it a polar rectangle. So what's r equals 0? That's just the pole, the origin. And then, like what's r equals 1/2? That would be a circle with radius 1/2. Or r is 3/4, a circle of radius 3/4. So what you can do is, the way you can think of this is this disk is a infinite union of circles. And now what about theta? Theta equals 0 is this line here that I'm highlighting. But like theta equals pi over 4 would be this line, pi over 2. So anyway, theta goes from between 0 and 2 pi. So now when I'm writing down the volume, it's going to be the integral over d of, say, fxy dA. But okay. But actually, right, okay. So in this situation, I'm going to have that this is the integral over d of 1 minus x squared minus y squared, because that is, as I have written down here, I didn't write fxy, but that's our surface. And actually, to be more complete, this is, this would be like the function on top, and then you subtract the function on the bottom, but the function on the bottom is just z equals 0. All right, now, but what I want to do is I want to put this in polar coordinates. So I'm going to go from theta equals 0 to 2 pi, and that's, okay, I'll just leave that over there. And then r goes from 0 to 1, and now I'm going to make a substitution. So we could maybe do this on the side of the paper also, is that for fxy equals 1 minus x squared minus y squared, we have these identities that we can use. In particular, x squared plus y squared equals r squared. So that this whole thing is equal to 1 minus r squared. And also, let me just write down not just identities, but the main identities that we're going to use are, there's just 3 of them. So let me write the word identities. Let me write neat. I'm just going to write the same thing, but more neatly. Identities, well, maybe not that much neater. Okay, I have x squared plus y squared equals r squared. I have x equals r cosine theta, y equals r sine theta. We need to know those, and we need to, substitute for x, y when we do these polar integrals. Okay? All right. Let's go back over here. So I have 1 minus r squared. Now, for dA, what am I going to write down? Anybody want to tell me? Go ahead.
I'm a little confused. Why does x squared minus y squared turn into r squared?
X squared plus y squared equals r squared?
Right, but do you factor out a negative or what?
Oh, yeah, that's true. I factored out negative. Okay, first of all, this is my box for the identities. Okay, so yes, I factored out a negative. So let me do more work here. This is 1 minus negative x squared plus y squared. So this is 1 minus r squared. Yeah, thanks. Okay, and then for dA, what am I going to write down for polar coordinates? Do you remember? dr d theta is almost right, but something's missing. This is a mistake I make, but I shouldn't. You have to put r. So do not forget. That's going to just give us the wrong answer. So you need to put, that's what dA is the dA is r dr d theta. You need to get that r there. Otherwise, it's just not right. Okay. So I have 0. Okay, first of all, notice that in this function, there's no theta. So actually, I can integrate 1 d theta times the integral of this 1 minus r squared r dr, if you want to do that. This is the integral of a constant 1, and so I multiply that constant times 2 pi minus 0. Or you can just, fundamental theorem of calculus, you get theta, antiderivative 1 is theta from 2 pi to 0 to 2 pi, you just plug that in. This is 0 to 1, r minus r third dr, so we get 2 pi. So r second power over 2 minus r to the fourth power over 4, and when I put in 1, r squared and r to the fourth are just going to be 1, putting 0, I get 0. So this is 2 pi 1/2 minus 1/4. So this is 2 pi times 1/4, and this gives pi over 2. So that's the volume of that region. Do you guys have any questions? All right. Goodbye, everyone. Click, like, subscribe. Thank you. Bye.